Good morning, my dear students. My name is Paulaj বিশ্বাস, Assistant Professor, JIS College of Engineering, Department of Mechanical Engineering, and today discuss coordinate systems. And this is the under my subject of computer-aided designs, and also this is lecture number 6. And the coordinate systems. Coordinate systems is considered according to what the computer graphics like as or the geometry. In geometry, a coordinate system is a system that uses one or more numbers or coordinates to uniquely determine the positions of the points or other geometric elements on a manifold such as uh, Euclidean space also will be considered according to what the coordinate system. You can see this is the one figures also will be considered according to this the three components. You can see according to the angle is the alpha, the beta, and also gamma angles also will be considered according to three axes: the x-axis, y-axis, and z-axis. During to this three axis, the different type of coordinates will be belongs during to these systems, and you have to consider that this will be the one coordinate systems, and the another is the this one and the this one, and basically the different coordinate systems will be considered to use the different positions, and according to your the movement on the, as like as your the rotations, translations, this will be considered according to your the different coordinates, and the systems will be considered. And you can see the according to your the different data, different number of coordinates will be considered according when you have to draw this the different type of figures, and also this will be translations, and also the rotations, and also the scaling will be considered according depends on this the different coordinate systems, and this will be comes from the geometry. Geometric coordinates also will become, and also during toward the 2D 3D transformations will be record of this the this coordinate systems will be applied. The order of the coordinates is the significance, and they sometimes identified by their positions in an ordered tuple, and sometimes by a letter, as in the x coordinates. And you have to see in here that this will be this is the horizontal component is considered as the x component, and also this vertical component is considered the y component, and similarly the this in between of this the x and y components, you have to consider the z coordinates. Also the z axis will be here. The similarly this is the by sometimes by a letter, as in the x coordinates also we can see the coordinates are taken to be real numbers. Is in elementary mathematicians, the mathematics also will be put in this here. That like your the coordinates are taken to be a real number in the elementary mathematics, but may be complex number or elements of a more abstract system, such as a commutative ring also you can see here. And another things, the use of coordinate systems allows problems in geometry to be translated into the problems about the number, and vice versa. In this the basics of analytics geometry is considered. Basically this is the coordinate systems, and sometimes you have to given some problems that allows some problems, you have to the translated like your the translations, and also the rotations, and the like as the scaling that you can this type of number, and also this will be vice versa is considerations. And you can see the this will be the coordinate systems as a part of reference systems will be considered. That's like you can see that this will be a figure is available, and to describe the satellite motions, it is necessary to have a well defined coordinate system. The or satellite systems, you have to always the well defined out as or the coordinate systems. Basically it is the central mathematical elements of more complex issues, that like the reference systems you have to given, that like the your coordinate systems always you to the movement of your the movement of all these coordinate systems, and like your the one reference planes will be considered, that like or the mathematicians you have to the more complex issues will be considered according to your the reference planes. Either your the reference plane your the not will be rotations, and not will be translations, and not will be scalings will be done during toward the either or the reference systems also will be considered, that like the reference systems is comes from this the different elements. A reference system consists of the adapted coordinate system, and in additions of a set of constants model, that like you can say that this is the set of constant models, and parameters will be given, that like the different parameters used to your the different parameters, different values will be putting in this places. Then you have to consider according to the different that like the left side of the parameters or reference gravity fields will be considered according to the central mathematician, as like as or the coordinate system, that like or the reference systems is the considered that like your the gravity field. You can see the general definitions of this the coordinate systems. You can see the a coordinate system is a system designed to establish positions with the respect to given reference points. Also, the coordinate system consists of one or more reference points will be required, just like your the one points will be, may be considered according to your the more points. And you can see that this figures will be given, that like your the x y and z axis you have to consider according to your the different coordinates, and also the different plane will be here, and according to your the on planes will be reference planes, and another will be rotations, and another points also will be considered according to your the reference planes. And you can see that this reference planes, and just like your the coordinate system consists of an one or more reference points. The systems of measurements, linears or angular, that like your the linears as like as the angular from those reference points, and the directions or axis in which those measurements will be taken. You can see the in satellite navigations various coordinate reference systems are used to precisely define the satellite and used locations, and basically the according to the different points you have to consider. So like use the 3 points will be coordinates will be given, that like x y and z value, and according to this the three consideration your points also will be depends on this the different places. Similarly, the according to the satellite navigations you have to given to this the which is the top positions will be here, and what is the vertical position, like that is the z axis, and what is your the reference points, and also the which coordinates you have to rotate according to this. This will be consideration that navigations and also various coordinates reference systems are used in the, you can see this figure, this is the various references systems will be considered the used to precisely defines the satellites, and user locations also will be considered according to the general definition. And also the classifications of the coordinate systems, and basically the coordinate system is the depends on this the different the way the according to the according with body of reference and location of a origin. A coordinate systems may be classified the topocentric, that links the use observer location as the center. Basically the topocentric also will be considered. You can see that this will be a figures will be given, and also suppose that this is the 3 points, and this is all the satellitic situations. The satellite navigations will be considered according to what the topocentrics, like the on the persons will be sitting here, the who is used to observer location as the center. The suppose that this will be the observer will be given, and this observer is concentrated to this the center of this satellites, and also the this is considered is called the topocentrics. And another things is here the geocentrics, that like the origin earth, the mass center is considered according to the geocentric, that like your the geometric centers will be concentrated according to this the earth, that like your the mass centers is considered. And another things the heliocentrics, that means the origin minus the sun, from this the origin to sun distance is considered according to the heliocentrics, and this heliocentrics is considered the origin, that like the this will be which place is considered as the origin of this the of your satellite visions, and also the navigations will be considered is called the heliocentrics. And another thing the selenocentrics, selenocentrics also the origin and also the moon, and this will be considered according to the distance between this moon to this the origin of the navigations will be considered the selenocentric also will be considered. And another thing is the depending on way the coordinates system set depending on this the way of this the coordinate systems, that like your the set in many way, maybe polar coordinate, polar and as like as the cylindrical and also the spherical, Cartesian, etc. also will be considered the different type of coordinates system, that like the depends on this the coordinates, the x axis, x y, and also the this is the polar coordinates also will be considered. And depending on this, the tropocentric and geocentrics are most common use for the purpose of the satellitic navigations will be considered according to your the tropocentric and the geocentrics. And you can see the polar coordinate system, that like your the polar coordinate system is the considered according to your the r and theta, that like your the radius and angular displacements also will be coordinate considered according to your the polar coordinate system, that like your the polar coordinate system is a two-dimensional coordinate system in which each point on a plane is determined by a distance from a fixed point and angle from the fixed directions will be considered the polar coordinate system. Basically the radius, that like your the distance from this the fixed line and also the fixed points, and again the you have to determine what is the distance, fixed point, and the angle from the direction, like the which direction you have to movement is found, and then you have to calculate it to this the theta value, that like you have to given this figure the according to this the 0 to, and you have to given to this the right direction, that like the L, it is means the this is the length, and again you have to consider the 360 degree, that means the 3 is the value of the radius or the distance from this the origin, and 60 degree is considered according to the angle from the which is the origin to this the which distance will be take up, that like your the which is the direction of angles will be calculated, that like your the 60 degrees value is found. And the cylindrical coordinate system, a cylindrical coordinate system is a three-dimensional coordinate system, that likes the you have to consider the three dimensions, suppose you have to consider the x, r and theta will be considered according to the cylindrical coordinate system. The cylindrical coordinate systems is a three-dimensional coordinate systems which is point is specified by the two polar coordinates, like your the two polar coordinates of its perpendicular projections not into some fixed plane, and by its signed distance from the that plane also will be considered according to your the cylindrical coordinate systems. And also this cylindrical coordinate system you have to see in this figure, and the according to the three-dimensional figure will be considered according to the cylindrical coordinate systems. You have to given to this the vertical component, horizontal components, and also the according to the cylindrical shape, that like you here the this cylindrical shape, and you have to 0 to a, and that like your the row, and also you have to on the cylindrical shape is found, that like your the phi, and also the vertical component is considered according to your the z components, and this z component that like your the 3D view you have to see, and during to this on the you find this value the rho sigma z, that like your the rho is the density of this cylinder, and also the say phi is considered is the angle of this, and also the z is the another vertical components also will be considered according to this the z axis, and like the three components will be considered the rho, phi, and also z components, and during to this the three-dimensional coordinate systems is considered the cylindrical coordinate systems will be given this figure. And another things will be considered the spherical coordinate system. The friends you know this the spherical coordinate systems is a coordinate system for three-dimensional space where the positions of a point is specified by specified by the three numbers, the radial distance, that the radial distance of that point from a fixed origin, its evolutions angle measured from a fixed plane, and the azimuth angle of its the orthogonal projections on the that planes will be considered. Basically this azimuthal and also the orthogonal angle projections will be comes during toward the sun, will be given some sign that like your the sun ray will be comes from the to this the earth, then you have to consider during toward the azimuthal angles, and also it's the orthogonal projections planes will be comes there. You can see this figure that like your the your the spherical shape, and this will be concerned according to the r theta and r theta, and also the phi value will be here. And basically this will be concerned according to this the the positions, the point of the three number, that like the one is the radial distance between the point from this the fixed origin will be coming. Basically that this will be the distance will be comes, that like your the r is given from this the fixed origin, and also the elevations, and basically this will be measured to this the angle measure from this the fixed plane, that like your the phi value will be calculated from this sorry, theta value is the calculated from this one. And this is the fixed plane, and also and the azimuth angle of this the its orthogonal projection. And basically this azimuth angles on the or this the orthogonal projection is calculated, that like your the phi value will be considered. Basically this is the depends on this the origin points, and also the which length will be distance will be covered, and also the which angle will be covered is the fastest from this the origin to this the which directions, and also your the elevations will be come up. And another things this will be considered according to your the azimuth angle, that like your the sun will be given sign, and also the shadow is created during to this the spherical coordinate systems. And another things is here that this will be given to this the Cartesian coordinate system. And as like your the Cartesian coordinate system, the specifies the each point uniquely in a plane by a pair of numerical coordinates. That like your the you can see the first is the left sides is the this will be the two components is considered according to the x and y components. And the x components you have to consider 0 is the x-axis, and the y components will be considered that will be the y-axis. And you can see the left figures, that like your the 0 0, and is the forward directions to this the x. And again you have to consider the 3 points is here, and the one is the 2 and 3 points will be considered according to this is the 2 and 3. And this is the basically the two dimensions coordinate systems will be given to this the 2 and 3. And another thing is that is the minus 1.5 is the 2.5 will be considered as the another points. And the another point is considered is the minus 3 and the 1. And this will be the these points will be the considered, that like your the pair of numerical coordinates which are the sign the distance from the point to point is the fixed perpendicular directions line, and also the measure in the same unit length also will be unit of length which will be considered according to this system. That like the this will be given to this the 3D figures, the according to your the 3D conditions, that like your the x, y, and the z axis will be here. And also you have to given to this the full concentration according to your the 3D dimension, that like your the what is the length of this your x axis, and what is the length of your the y axis, as like as your the z axis. The all things also will be properly known, and the which distance will be covered according to your the Cartesian coordinate systems. And which will be the height, and also the base, the all things also will be known during toward the Cartesian coordinate system. And there is the no difficulties will be come up according to this the systems. And also the perpendicular distance line whether in the same units, and also the length also will be considered. Basically the x and y, x, y, and z, there is the no angle also will be calculated during to this systems, and only this will be calculated from this the which distance is the covered according to this direction. That's like your x, y, and z. Basically you have to putting this value as like as the two dimension system, that's like your the x, y coordinates. And similarly you have to putting this value of the z value according to your the z coordinates, and also the z axis. You can see the geographic coordinate systems also will be considered. Suppose our the different geographic figures we can see that like our the earth will be movement during toward the own orbits. And also the you have to give it to this the earth also will be rotates according to your the own orbits, then this will be also considered according to your the coordinate systems will be here. And this is the basically considered the geometric coordinate systems. The geometric coordinate systems enables every location of earth to be specified in the three coordinate systems, that like the latitude, the longitudes and also the heights will be considered. Basically, when the earth is the movement in the each and every concentrations in the every points, you have to point. Suppose when we have to movement from this the one place to this the another place, then the each and every place, the stepping we have to given this the one coordinate systems will be found. Similarly, the geographic coordinate systems or the earth, and this will be comes to this the different the step by stepping will be given, and during to this the different steps will be depends on this, the different latitude also, and also the longitudinal longitudes, and also the different heights also will be considered, and the which heights this will be easy, and the which height this will be the difficulties will be comes, and but the each and every places we have to found a coordinates, and basically this coordinates is considered according to your the geographic coordinate systems, and it based on the spherical coordinate system, just like the coordinates are angular values will be found. Basically, the different values that like your the latitude, longitudinal, and also the heights, this will be comes during toward the, this is that on globes will be given here, and also the you have to topocentric points you can see that like your the origins, and also given toward the lights will be passes through this, and we have to calculate it that like or the navigations will be comes here, and during to this procedures the very easily you have to concentrate according to your the geometric coordinate systems, and either the any type of geometric coordinates, this graphics is not will be fully satisfied according to your the definition, and also the up to the marks, and of also the this will be spherical coordinate systems will be here, and another things you have to consider, the geographical latitude also will be considered. Suppose the different type of the geographical latitudes also will be given, that like your the different abbreviations, the letter that like the phi or phi is here, that is the angle between the equatorial plane and the normal that passes through user location points also will be considered according to the user location points, and another things, the geographical latitudes that like the abbreviations, the long lambda will be considered, or the lambda, and basically is the angle between the reference meridians, and that is the green wheels, and another meridian, and the meridians that passes through user locations points also will be considered according to the geographical latitudes, longitudes also will be here, and basically you can see the this will be on the globes you can see, and also you have to concentrate according to this the topocentrics, and also the this is the different movements also will be under different latitudes, and also the different angles value will be calculated and also given to this the systems, and then you have to consider that what is the geographical latitudes, and what is the geographical longitudes, and then you have to calculate, and the which will be movement of this, and also which coordinates will be obtained according to your the navigations, and according to your the movement of your earth through your the own orbits, this will be calculated here, and another you can see the earth centered earth fixed that like the ECEF you have to concentrate here, that like the earth centers, that like your the EC, and another thing is the earth fixed. Suppose your a few cases you have to consider your earth will be fixed, and also the you have to consider according to the earth is centered, and the EF is a geometric Cartesian coordinate systems is here. The during to your the geometric Cartesian coordinate system, it represents positions. Represents which is the represents that like your the positions as x, y, and the z coordinates. You can see the first figures. First figures you have to consider according to the x, y, and z coordinates. That like your the one center point will be considered, and just like your the you have to given this the coordinate, just like your value is putting here the 0 0 0, that like the this point the 0 0 0 is defined as the earth mass center will be considered, that like your the center of mass will be considered according to this the earth, that like is here the 0 0 0, and another things is the second one will be considered, that like your the first figure you have to concentrate according to the mass of this earth, but the according to this concentrations, you have to movement to this the another places. Then this the places you have to suppose your coordinates will be changed, that like your the 0 on 0 and 0, then you have to slightly change his positions, and another cases you have to consider, suppose your the positions will be changed for this the on minus 1 and on, this will be the movements will be found, then this will be change your positions, and also the coordinates also will be properly changed according to this systems. And during to this, the z-axis is defined as being parallel to the earth rotation axis. The pointing towards north also will be considered. But basically, this will be movement towards the north, and sometimes we have to see the during to this movement towards the from towards the east to west also will be considered. That like you have to like example, that is like the x-axis is defined as the being parallel to the earth's rotational axis, that like the pointing towards the north. And another things, the x-axis intersect the sphere of the earth at the 0 degree latitudes and the 0 degree longitudes. And basically previous the slides already discussed the longitudes and the latitudes, and like the 0 degree longitude and also the 0 degree latitudes will be considered according toward the x-axis toward the spheres. And another thing, this means the ECEF rotates with the earth around its z-axis, that like the z-axis will be considered. And another things, the y-axis is orthogonal to both of them, making the system directly oriented. Basically this will be the third figure you have to consider, that like the datum A and also the z-axis and x and y-axis you have to consider according toward the x axis the orthogonal to both of them, making the system directly oriented. And the internal and non-internal reference systems will be discussed. An internal reference system is a coordinate system in which Newton's law of motions are valid, that like the internal reference frames are neither rotating or accelerating also will be considered according to an internal reference system. Basically this will be considered according to the Newton law of motion. Another things, the in non-internal reference systems is considered the is a system that is undergoing accelerations with respect to an internal systems will be calculated. Basically this will be the internal and non-internal systems depends on will be depends on this the Newton's law of motions. Another is the not will be depends on this will be respect to the internal system, the acceleration with the respect to the internal systems will be considered, that like the reference systems. And you can see the earth center internal, like the ECI is also a geometric Cartesian coordinate system, that like but unlike ECEF, the ECI fixed with the respect to the stars and the doesn't rotates with the earth. And another things, the XY planes coincides with the earth equations planes, like the x-axis is permanently x-axis is the permanently fixed, and in a directions relative to the essential, the spheres also will be considered, that like the another sphere here the which does not rotates like the earth does. And another things, the z-axis lies at a 90 angle to a equilateral and also a plane, and extends through the north pole will be considered according to this movement, that like the north to south movements also will be found, and that like the north pole. And these things, and the earth rotates, the ECI coordinate system does not will be rotates according to the earth centric internal is here. The world geodetics geodetic systems also will be here. The all geodetic system is a earth centered, and also the earth fixed, the terrestrial reference systems and geodetics datums also will be considered. The WGS is the 84 is based on a consistent set of constants and model parameters that describes the earth size, shapes and gravity, and also the geometric fields is the considers. The WGS 84 is the reference system for the global positioning system, that means the GPS, and the PZ 90.02 is the reference system for the GLON ASS. And another things, the parameters, the PZs is the 9002, and the WGS 84, the art rotations rate is the QZ, the 7.292, 1 on 5 into 10 to the power minus 5, and speed of this the lights will be calculated here, the 299 792,485 meter per second. GM mu equals to is given value, the semi major axis, and the flattenings in the F will be considered according to this figures. And another things, the definition of coordinate systems will be of WGS, that means the 84 and the PZ 90.02 are close to each other. The Nevertheless, the realizations of the WGS 84 and the PZs 90.02 may use their own sets of the stations with the definite coordinates. Thus, the difference between WGS 84 and PZs 90.02 coordinate systems may very likely take place, but this differences is less than 0.5 microns. Will be given. This will be figure the systematics inaccuracy format. Formed at the transactions from the WGS 84 is the PZ 90.02, and others commonly used systems, you can see the some others common coordinate systems are the following. Cavalier coordinate system are the generalizations of the coordinate system. Generally, the system is based on this the intersections of curves, the orthogonal coordinates, the coordinate surfaces meet at right angles. Skew coordinate systems, the coordinate surfaces are not orthogonal. The long polar coordinate system represent a point in the plane by the logarithm of this the distance from the origin, and an angle measures from a reference line intersecting the origins. And you can see the Lucar coordinate systems are way of representing lines in 3D equivalent in space using the 6 tuple of numbers. A homogeneous coordinates also here. The generalized coordinates are used in the Lagrangian treatments of this mechanics is here. And another, the canonical coordinates are used in the Hamiltonian treatment and of mechanics. And also the barycentric coordinate systems are used for ternary plots, and more generally in the analysis of the triangles is considered. And the Trilinear coordinates are used in the context of the triangles. There are ways of describing curves without coordinates using the intersect equations that use invariant quantities such as curvature and arc lengths will be considered. This includes the Whale equation related arc length, and the tangential angles is considered. The Cesaro equations related arc length and curvatures will be considered according to this. And orientation based coordinates in geometric and the kinematics coordinate system are used to describe the linear positions of points and the angular positions of axes, planes, and rigid bodies will be considered. The in the latter case of this orientations of second, and that like the coordinate system fixed to the nodes is defined based on this the first will be considered the first coordinate system, that like got the global. And for instance, the orientations of a rigid body can be represented by an orientation matrix which the includes in the 3 columns the Cartesian coordinates, and the 3 points will be considered. These points are used to define the orientations of the axis of the local systems. They are produced of 3 units vectors aligned with this axis is considered. And the next um, classes we can discuss the 2D and 3D transformations. Okay students, this class is already covered the different type of coordinate systems, and also the different type of which places will be used. Okay, thank you students.